Throughout the company's over 50-year history as a semiconductor manufacturer, Intel has delivered a range of innovative process technologies. Today, Intel is building on this legacy by introducing two groundbreaking innovations to enable the next generation of higher performance products. Introducing RibbonFET, which will be Intel's first new transistor architecture since the introduction of the FinFET in 2012. Ribbon-shaped channels are surrounded by the gate, which means better control and a higher drive current at all voltages. This delivers faster transistor switching speeds, which ultimately enables higher performance. With one stack of nanoribbons, we can achieve the same drive current as multiple fins, but in a smaller footprint. And the flexibility of the RibbonFET design enables the width to be modulated to accommodate multiple applications. Beyond RibbonFET, Intel's relentless quest for performance led it to look beyond transistor design for additional gains. Enter PowerVia. PowerVia will be a first-of-its-kind backside power delivery scheme that solves one of the biggest issues facing computing today: interconnect bottlenecks. Traditional interconnect technology sits on top of the transistor layer, with all of the power and signal wires integrated. With the new PowerVia design, the power wires are placed underneath the transistor layer on the backside of the wafer. Power is now delivered directly from the package to the transistors through a network of metal layers that are better optimized for this function. Dedicating the bottom side of the wafer to power delivery and the top side to signal routing is simply a better organization of resources. By eliminating the need for power routing on the front side of the wafer, more resources become available to optimize signal routing. The overall result is a significant frequency boost at the IP block level and a reduction in power leakage. The connection to the transistor layer is made through an innovative nano TSV, or through silicon via, which is 500 times smaller than TSVs used in today's most advanced packaging technologies. The combination of RibbonFET and PowerVia will enable Intel to deliver increased computing performance for the workloads of the future.
This is Intel's new efficient x86-core microarchitecture, designed for throughput, enabling scalable multi-threaded performance for modern multitasking. The front end starts with a 64 kilobyte instruction cache with 64 bytes of read bandwidth. Smart branch predictors improve the flow of code down the instruction pipeline. This microarchitecture features two out-of-order decode clusters, each with 3 parallel decoders. enabling a peak throughput of 6 instructions per cycle. It offers on-demand length decode for large code footprint workloads. While keeping latency and power low, it efficiently feeds the wide backend for optimal performance. 5 wide allocation, 8 wide retire, and 17 execution ports, this new microarchitecture offers a great level of parallelism and performance. Dual load plus dual store pipelines enable symmetric read and write bandwidth for demanding usages. The inclusion of AVX in the ISA and hardware with VNNI provides support for integer AI operation and dual floating point fused multiply add. Shared amongst the core cluster is a large Level 2 cache, configurable up to 4 megabytes and optimized to work seamlessly with other CPU core microarchitectures. The new efficient x86 core redefines what is possible for power-efficient throughput compute by enhancing Intel's architecture portfolio that matches the right cores and IP. It delivers truly transformative products, high performance and experiences that matter in the real world.
VMware vSphere has become the compute virtualization platform of choice for many enterprises to get more for less out of their data center by improving infrastructure utilization and TCO. But containing IT spend has grown more difficult because vSphere deployments require large memory capacity, while DRAM's price per terabyte continues to climb rapidly, making memory the overwhelming proportion of system purchase costs. Enter Intel Optane Persistent Memory, with its breakthrough combination of memory capacity, performance, and cost efficiency. VMware vSphere is optimized to take advantage of those benefits, and that enables you to slash server costs by deploying platforms with the same memory capacity as before, but at much lower cost. Or extend memory capacity per server to increase consolidation, enabling you to run 25% more general-purpose VMs per server, while decreasing costs by 30% due to lower CapEx, OpEx, and licensing expenses. Increasing consolidation also reduces server footprint and data center sprawl. Be certain you're getting the most out of your virtualized deployments with the advantages of vSphere and Intel Optane Persistent Memory. Find out more by visiting us on the web.
For decades, Intel has delivered relentlessly to help secure your business, and we continue to do that with Intel Hardware Shield. Intel Hardware Shield, available exclusively on the Intel vPro platform, provides enterprise-class security features for business. Intel Hardware Shield includes below-the-OS security, application and data protections, and advanced threat protections. We know that workloads are expanding and threat models evolving. That's why our vision for security architecture starts with foundational security to deliver a solid base to build upon. Intel has a proud history of delivering hardware-based security innovations that help systems boot up correctly and run as expected. Intel engineers have been working on security challenges in earnest since co-inventing the Ethernet in the 1980s. They pioneered the concept of hardware root of trust in the 1990s, and Intel has been an industry leader in this field ever since. This hardware-based approach starts below the operating system. Intel Hardware Shield locks down memory in the UEFI BIOS to help prevent planted malware from compromising the operating system. It also helps launch your PCs in a trusted state. With that solid foundation, you can isolate workloads with Intel's collection of capabilities to better protect applications and data with hardware-accelerated isolation and encryption. To better detect and respond to advanced threats, Intel delivers the industry's first and only silicon-enabled AI threat detection to help stop ransomware and crypto mining attacks for Windows-based systems. And to help defend against control flow hijacking, our Intel engineers invented groundbreaking technology to help shut down an entire class of attacks that long evaded software-only solutions. Naturally, securing your business requires more than technology features. Intel security assurance programs help keep your business safe with industry-leading support. Intel's leading bug bounty program invites the security research community to partner, discover, and eliminate issues. Intel builds products with security integrated at every step, backed by dedicated teams evaluating security resilience. The Intel platform update process proactively and transparently enables product security updates across the ecosystem. Intel has unrivaled product security incident response with coordinated processes to help keep your business safe. Intel, with our decades-long commitment to product security throughout the lifecycle, delivers groundbreaking hardware-based capabilities and an unwavering commitment to help eliminate cyber threats yesterday, today, and tomorrow. Security is in our DNA. Software alone is not enough for IT security. It's time to add hardware security to your requirements for new PCs. Ask your Intel rep how Intel Hardware Shield and Intel Security Assurance can help secure your business.
Now more than ever, people depend on their PCs to learn, work, create, and have fun. And it's vital that PCs reflect the real-world multi-use experiences people do every day in order to keep up with their busy lives. To stay ahead of the growing demand for compute performance, PCs must become not only faster, but more purposeful and adaptive. Introducing the all-new 12th Gen Intel Core processors. Intel's most significant shift in x86 architecture in more than a decade. These processors introduce Intel's first performance hybrid architecture with 2 all-new Core microarchitectures instead of 1. The Performance Core, or P-Core, is the highest performing CPU core Intel has ever built, maximizing single-thread performance and responsiveness. The Efficient Core, or E-Core, delivers scalable multi-threaded performance plus efficient offload of background tasks for modern multitasking. In order for these cores to work seamlessly with the operating system, Intel has built new intelligence directly into the hardware called Intel Thread Director. By carefully monitoring and analyzing in real time, Thread Director guides the operating system to place the right application thread on the right core at the right time to deliver incredible performance and responsiveness. Based on the workload, background activities and tasks that can be run in parallel like image rendering may be efficiently offloaded to the E-cores, unlocking the massive performance and responsiveness of the P-cores for compute-intensive workloads like 4K gaming and 3D design. 12th Gen Intel Core processors are Intel's revolutionary new approach to x86 architecture. Dynamic, adaptive, and purpose-built for real-world performance, unleashing human potential like never before. 12th Gen Intel Core processors, delivering superior performance where you need it most.
Making a computer chip is probably the most complicated process in the world. It takes thousands of engineers, hundreds of multi-million-dollar tools, factories the size of 4 American football fields, and billions of microscopic switches called transistors. And before a working chip winds up in a PC, data center, or another computing device, it goes through a battery of temperature, stress, performance, and quality tests. We're about to show you a few of these fascinating tester tools. Come with us as we go behind this door. We're in a high-volume test factory in Oregon. It's part of Intel's Assembly Test Technology Development Group, or ATTD. ATTD is one piece of Intel's manufacturing juggernaut. Here, engineers research and develop the latest testing equipment and processes before they pass them on to our high-volume manufacturing factories that test chips by the tens of millions every day. This tool is called a sort module. It's the size of a small school bus. It's made up of 20 individual test cells, each about 5 by 5 feet square. Inside each test cell, thousands of chips are sorted and tested to check for defects and measure their performance. Each test cell weighs about 1,000 pounds. At times, cells are removed from the sort module with a custom-designed lifter mechanism. The lifter is moved around the floor by this TC runner, which floats on a cushion of air like a hovercraft. Without this runner, the tester and the lifter are so heavy they would literally destroy the factory floor. This device is called a probe card. The probe card physically touches the chip to connect the integrated circuits inside to the test equipment. It measures the electricity of the chip's circuits for reliability and defect analysis. The probe card uses small micrometer-sized metallic needles to connect with contact pads on the chips. Some products may require as many as 20,000 probing needles in an area of just a few square centimeters. Each probe needle is thinner than a human hair. Once good chips leave Oregon, they're sent to Arizona to be assembled between a heat spreader and a substrate. This package protects them and connects them electronically to a computing device's circuit board. Behind this door in Arizona, packaged chips undergo even more quality checks. On a side note, some of Intel's most valuable tools live here as well. They manufacture our advanced packaging inventions called EMIB and Foveros, which allow us to interconnect multiple chips on a single package. These machines give Intel its packaging leadership. Now back to ATTD. The 3 test modules and software you are about to see are all designed by Intel engineers. This is the high-density burn-in module. There are so many chips tested per cell and so many electrical pins per device that this tool must provide an exceptionally large socketing force, about 3 metric tons. That's the equivalent of a Chevy Suburban on top of each cell. That's a lot of force. Like Oregon's sort module, this massive tester checks the speed and performance of the chips at extreme temperatures, from 110 Celsius to as low as minus 40 degrees Celsius. The final step in the test flow is system test, where each packaged chip gets socketed to a motherboard to simulate real-world customer conditions. This tool runs chips on different operating systems such as Windows and software and graphics applications to ensure our final products work for customers. You are most likely watching this video on your computing device, a device being run on a chip that underwent thousands of manufacturing steps and hundreds of quality tests. Hope you enjoyed going behind this door with us. Thanks for watching. I'm Rob Kelton.
Throughout the company's over 50-year history as a semiconductor manufacturer, Intel has delivered a range of innovative process technologies. Today, Intel is building on this legacy by introducing 2 groundbreaking innovations to enable the next generation of higher performance products. Introducing RibbonFET, which will be Intel's first new transistor architecture since the introduction of the FinFET in 2012. Ribbon-shaped channels are surrounded by the gate, which means better control and a higher drive current at all voltages. This delivers faster transistor switching speeds, which ultimately enables higher performance. With one stack of nanoribbons, we can achieve the same drive current as multiple fins, but in a smaller footprint. And the flexibility of the RibbonFET design enables the width to be modulated to accommodate multiple applications. Beyond RibbonFET, Intel's relentless quest for performance led it to look beyond transistor design for additional gains. Enter PowerVia. PowerVia will be a first-of-its-kind backside power delivery scheme that solves one of the biggest issues facing computing today: interconnect bottlenecks. Traditional interconnect technology sits on top of the transistor layer, with all of the power and signal wires